Welcome to our channel Sankalp Study Success. Till now we have seen what is NFA and what is DFA, and we have also seen how to construct an NFA and how to construct a DFA. But in this lecture we are going to see how to convert NFA into DFA. That means conversion of NFA to DFA, or you can also say that it is an equivalence of NFA and DFA. So it is an equivalence of NFA to DFA, or it is also known as conversion of NFA to DFA. So now, how to convert NFA into DFA? See, if there exists an NFA, then there will be an equivalent DFA. So if there exists an NFA, then there exists a DFA which stimulates the behavior of NFA. If L is a set accepted by NFA, then there exists DFA which also accepts L. L is nothing but the language which is generated. That language, it is accepted by NFA. Then the same language will also be accepted by DFA. So here the finite, if you consider M1 is the machine of NFA and M2 is the machine of DFA, then language which accepts M1 will be equal to the language which accepts M2. That is, for each and every NFA there exists an equivalent DFA. So now, how to convert, what is the procedure to convert NFA into DFA? Now let us see what is the procedure. The first step is you have to find out Q dash. See here, if M is equals to Q sigma transition function Q0 comma F, it is a 5-tuple notation of NFA, then there exists another machine. If it is M1, then there exists another machine M2 in such a way that Q dash sigma, which is same for both NFA and DFA, transition function dash comma Q0 comma F dash. This machine is for DFA, which is also a 5-tuple notation. So here the set of states in NFA and DFA are generally, the transition function is different for both NFA and DFA, as we know. For DFA, if you consider, transition function maps from Q cross sigma tends to Q, right? Which we have already seen. But for NFA, the transition function maps from Q cross sigma tends to 2 to the power of Q. So that means transition function of NFA is different from transition function of DFA. That's the reason it is transition function and transition function dash. So if Q is different and here it is 2 power Q, then the set of states from NFA to DFA will also differ. So it is Q and Q dash. And also, if the set of states differ, then the final state will also differ, because final state is a subset of Q. So F and F dash are different, but any input symbol which you are applying to NFA will be same for the DFA also. So sigma and sigma are one and the same. And what is, if the initial state of NFA is Q0, then the same initial state will be there for DFA also. So here Q dash is calculated as 2 power Q, and here you will find out the F dash from the FA only, that is from NFA. Whatever the final state is given in NFA, according to that final state we are going to consider the final states in DFA. And then transition dash, we need to find out the transition dash. Here first we will start with the initial state and apply all the input symbols given in the question. So if by finding the transition dash, that means here transition dash of Q0 comma A, for example, transition dash of Q0 comma A will become transition of Q0 comma A. This is the formula. Transition dash of Q0 comma A is equals to transition of Q0 comma A. That means if you are finding out the extended transition function, we are going to start it from the initial state. For the initial state, you are going to apply all the input symbols which are present, and the answer of the extended transition function is the new state. Then you are going to again find out the transition dash of those new states. And again, if you get the new state, then you will continue the process. But if there is no new state, that means the answer is already the existing state, then you will stop it over there. Till all the new states getting generated is completed, then you will stop the process. Otherwise, the process continues till no new state is generated. See here, if there is no new state generating, then stop the process after finding all the transitions. So, this is a bit typical to understand, but let us solve the problem so that it will be very clear and it will be the easiest one to solve. So, let us see the first question where m is equals to q0 comma q1, that is q is equals to q0 comma q1. We have to write the given data and sigma is equals to 0 comma 1, which is given. Q0 is the initial state and Q1 is the final state. That is final state Q1. Here, now let us draw the transition diagram, because here transition of Q0, Q0 comma 0, Q0 comma 1, Q1 comma 0 and Q1 comma 1 are given. That means let us draw the transition table. There are only two input symbols, sigma is equal to 0 comma 1, and there are two states which are Q0 and Q1, where final state is Q1 and the initial state is Q0. Now let us substitute the values given in the question. Transition of Q0 comma 0 is nothing but Q0 comma Q1, which is Q0 comma Q1. Now transition of Q0 comma 1 is equal to Q1. Here transition of Q1 comma 0 is equals to 5 and transition of Q1 comma 1 is equals to Q0 comma Q1. So this is the NFA which is given in the question. Now we need to construct an equivalent DFA. So the first step is we are going to start from the initial state, which is Q0 comma 0. For Q0 comma 0, it is nothing but transition of Q0 comma 0, which is equals to Q0 and Q1, that is Q0 comma Q1. Till now we have done only for Q0. So if you apply an input symbol 0, then you got Q0 Q1, which is a new state. So again we need to find out for the new state. First of all, we need to find out for both the input symbols. So let us find out for 1 as well. Q0 comma 1, that is nothing but transition of Q0 comma 1. Transition of Q0 comma 1 is Q1. That means here we got both the new states. Both the states are new, only Q0 is done here. So let us find out for Q0 and Q1. So here transition dash of Q0 comma Q1, which is a state here, we are applying 0 to this state. Now it is nothing but transition of Q0 comma 0 union transition of Q1 comma 0. So what is transition of Q0 comma 0, which is Q0 Q1, and Q1 comma 0 is nothing but 5. So our answer is Q0 comma Q1. Here it is not a new state because already this state has been existed. That means Q0 comma Q1 we are already processing it. So there is no need to find out for Q0 and Q1 again and again. Now we are going to apply 1 for the Q0 and Q1 because we have already applied 0 as the input symbol. Now we are going to apply 1. So if you apply 1 for the Q0 and Q1, then it is nothing but transition of Q0 comma 1 union transition of Q1 comma 1. Here transition of Q0 comma 1 is nothing but Q1 and transition of Q1 comma 1 is nothing but Q0 and Q1. So it becomes Q0 and Q1. Already Q1 is present here. So we need to write for only ones. So by applying 0 and 1, we got both the answers as Q0 Q1 and Q0 Q1, which are not the new states. So let us leave it. One more new state is left out, which is Q1. So Q1 comma 0, transition of Q1 comma 0. Here transition of Q1 comma 0 is nothing but 5, which is equals to 5. Now transition of Q1 comma 1. which transition dash of q1 comma 1, which is equals to transition of q1 comma 1, which is q0 and q1. Here in this case, there is no new state has been generated. Already this q0, q1, we have already found the transition dash of q0 and q1. So there is no new state generated. So we will stop our process here. Now let us draw the transition table for transition dash. So now for DFA, transition dash and 0 and 1 are the same input symbols, and here we are having q0, q1 and also q1. These are the states which we have in DFA, because these states we got by processing it, right? So now if you apply 0 to q0, we got q0, q1. If you apply 1, we got only q1. So let us write it here, q0, q1 and q1. By applying 0 to q0, q1, we got both as q0 and q1. q0, q1 and then again q0 and q1. Now if you apply 0 and 1 to q1, first we got 5, then we got q0, q1. So in this way we are going to draw the transition table. Now let us draw an equivalent DFA, that is the transition diagram for this transition table. There are two states q0. First of all, let us find out what is the final state. This is the initial state, as we know, because q0 is the initial state in NFA. Now let us find out the final state. Final state is q1. So wherever the q1 is present in these states, those states are the final states. So this is the final state and this is also the final state, because there is a q1 here. Here there is no q1, so only these two states are the final states. So that means this is the initial state. By applying 0 to q0, we are going to q0 comma q1, which is the final state here. That means it is surrounded by two circles. By applying 0, now by applying 1, we are moving to q1. That means, which is also a final state. Now for q0, q1, if you apply 0 and 1, it is moving to the same state, q0 and q1. That means you can apply a self loop with 0 and 1. Now there is no transition for 0. That means if you apply 0 to q1, then there is no transition, and if you apply 1 to q1, then it is moving to q0 comma q1. So this is the equivalent DFA for the given NFA. In this way, we are going to solve the problems of converting NFA into DFA. These two conversions, NFA with epsilon to without epsilon and also NFA to DFA, are the most important questions which you can expect from unit 1. So here we have found first we have written the given data, and then from the initial state you need to find out the transition dash by applying all the input symbols. Then if the answer of that is the new state, then you will continue with the process by applying all the input symbols. But if there is no new state generated, then we will stop our process there. Then we will continue by drawing an DFA for the equivalent NFA. So now let us solve one more question, which is convert given NFA to DFA. Here directly the question transition table is given in the question. Now let us start finding out the transition dash of from initial state, which is q0, by applying both 0 and 1. Transition dash of q0 of 0 is nothing but transition of q0 comma 0, which is equals to q0 comma q1. Now we are going to apply 1 to the q0, that is q0 comma 1, which is equals to transition of q0 comma 1. Here transition of q0 comma 1 is equals to q0. That means q0 is not the new state which is generated, because already q0 is completed here. But q0 and q1 are the new states which are, it is a new state which is generated. So now let us solve it for q0 and q1, that is transition dash of q0 comma q1 if you apply 0 to this state, then it becomes transition of Q0 comma 0 union transition of Q1 comma 0. Then it becomes Q0 comma 0 is Q0 and Q1, Q0 comma Q1, and if you apply 0 to Q1 it becomes Q2. That means we have to include Q2 also. So it is again a new state which is generated. Now we need to apply Q0 Q1 with 1. This becomes transition of Q0 comma 1 union transition of Q1 comma 1. Here Q0 comma 1 is nothing but Q0 and Q1 comma 1 is Q1. So Q0 and Q1, which is not the new state generated here. So we are going to solve it for only Q0, Q1 and Q2. So transition dash of Q0, Q1, Q2, if we are applying 0 to this state, then it becomes transition of Q0 comma 0 union transition of Q1 comma 0 union transition of Q2 comma 0. That means Q0 comma 0 is nothing but Q0 Q1 and Q1 comma 0 is nothing but Q2, Q2 comma 0 is nothing but Q3. So this is again a new state which is generated. Then here we need to apply input symbol 1 to this state. So Q0 Q1 Q2 comma 1. Here it becomes transition of Q0 comma 1 union transition of Q1 comma 1 union transition of Q2 comma 1. Then Q0 comma 1 becomes Q0, Q1 comma 1 becomes Q1 and Q2 comma 1 becomes Q3. That means both are the new states which are generated here. That means for both the states we have to apply 0 and 1 input symbols. So now let us continue the process by applying 0 and 1 to this state which is Q0, Q1, Q2, Q3 and Q4. That means transition dash of Q0, Q1, Q2 and Q3 comma 0. That means it is transition of Q0 comma 0 union transition of Q1 comma 0 union transition of Q2 comma 0 union transition of Q3 comma 0. That means Q0 comma 0 is Q0 Q1, this is Q2, this is Q3 and this is 5. That means we are going to get the same state again Q0, Q1, Q2 and Q3. So there is no new state generated. We are going to end it here and then we are going to find out for 1. That is Q0, Q1, Q2, Q3, comma 1. So it becomes transition of Q0, comma 1, union transition of Q2, comma 1, union transition of Q3, comma 1. Sorry, I missed Q1, right? Q1, Q2 and union transition of Q3, comma 1. Then Q0 comma 1 is Q0, Q1, Q2 and Q3. That means we are going to get the same state Q0, Q1, Q2 and Q3. So now there is no new state generated, but here there is one more state for which we need to apply 0 and 1, which is Q0, Q1 and Q3. That is transition dash of Q0, Q1 and Q3 comma 0, which is equals to transition of Q0 comma 0 union transition of Q1 comma 0 union transition of Q3 comma 0, which is equals to Q0 0 is Q0 Q1. Here Q1 0 and Q3 0. Q3 0 is anyhow 5. Q1 0 is Q2. Q0 Q1 and Q2. Now let us apply for 1. Q0 Q1 Q3. We are applying input symbol 1. So this becomes transition of Q0 comma 1 union transition of Q1 comma 1 union transition of Q3 comma 1. So Q0 comma 1 is nothing but Q0. Q1 comma 1 is Q1. Q3 comma 1 is Q2. That means Q0, Q1 and Q2. Here, let us see Q0, Q1 and Q2 is the new state or not. No, Q0, Q1 and Q2 we have already processed. That means this is not the new state. So we are going to stop it here. How many states did we get till now? This is one state. This is the second state. This is the third state. And this is the fourth state and this is the fifth state. That means we have got 5 states till now. So let us draw the transition table, which is transition dash, transition function dash and 0 and 1. And here you are going to have the states, which are nothing but Q0, which is the initial state actually. Then we got it as Q0, Q1. Then let us see what are the next states which we got. Q0, Q1, Q2 and then all the 4. Q0, Q1, Q2. Then all the 4. Q0, Q1, Q2, Q3. Then the last one is Q0, Q1, Q3. Now let us find out what are the final states. That means Q2 is the final state in NFA. That means here there is a Q2, it is a final state. Here there is a Q2, it is a final state. So there are only 2 final state in the equivalent DFA. So let us write the values of Q0. For 0 we got it as Q0, Q1 and for 1 we got it as Q0. For Q0, Q1 we got it as Q0, Q1, Q2. And for 1 we got it as Q0 and Q1. For Q0, Q1, Q2 we got it as Q0, Q1, Q2, Q3. And for applying 1, Q0, Q1 and Q3. Now for Q0, Q1, Q2 and Q3, by applying 0 and 1 we got both the same states, which is Q0, Q1, Q2, Q3 and also Q0, Q1, Q2 and Q3. Now for Q0, Q1, Q3, if we apply 0 then you will get it as Q0, Q1 and Q2, and even if you apply 1 you will get it as Q0, Q1 and Q2. So these are the answers which we got by solving these transition function dash of each and every state. Now let us draw the transition diagram for this equivalent transition table. So let us take 5 states which are Q0, which is an initial state. So by applying 0 you are going to Q0 and Q1. That is Q0, Q1, which is not a final state, it is just one of the states. So by applying 0 we are going to Q0 and Q1. So by applying 1 we are going to Q0 itself. So this is the first one. For the second one, Q0 and Q1, if you apply 1 it is going to Q0 and Q1. So there is a self loop here. But if you apply 0 we are going to Q0, Q1, Q2, which is a final state. So Q0, Q1 and Q2, which is a final state. By applying 0. So now if you apply 0 to Q0, Q1, Q2, it is going to Q0, Q1, Q2 and Q3. That means if you apply 0, it moves to Q0, Q1, Q2 and Q3, which is again a final state. And now if you apply 1 to Q0, Q1, Q2, it is moving to Q0, Q1 and Q3. Now if you apply 0 and 1 to Q0, Q1, Q2, Q3, then it is moving to the same state. So we are going to have a self loop with 0, 1. And for Q0, Q1, Q3, if you apply 0 and 1, it is moving to Q0, Q1 and Q2. So it is moving to Q0, Q1 and Q2 by applying both the input symbols 0 and 1. In this way, we are going to solve the problems of conversion of NFA into DFA. So for every NFA, we are going to have equivalent to DFAs. So these are the most important questions. The first is conversions Conversions are most important. In this conversions, first one is NFA with epsilon to NFA without epsilon, and also the second one is NFA to DFA. So these are the most important problems from unit 1. So thank you for watching the video.